Hello everybody, and here is the video on the 4 states of matter that we will cover in 8th grade. There are a few more, but we stop at these 4: solid, liquid, gas, and plasma. So get your notebooks ready to go and take some notes. These should be fairly simple notes to take. So there are 4 states of matter. Recall that this is a physical property. This means that just because a substance changes from a solid to a liquid, for example, an ice cube melts and becomes water, it's still the same substance chemically. It never changed. It was just frozen water and then it became liquid water. If you click here, this is a live link within the notes. You can read about these 4 states. There are also some short videos. And here as well there is some information about what the molecules do, how they behave in those states, and we will dive deeper into that in the next few slides. And lastly, we don't have plasma represented very well, but it is basically an electrically charged gas. It does take the shape and volume of its container, just like a gas, but there's also electricity going on in there. Okay? So solids, you can click here to read more about solids. This is the lowest energy state. The molecules are packed into place. They are stuck there, meaning they cannot switch places. That doesn't mean that you can't bend the substance depending on what the substance is. They have a fixed or definite, those mean the same thing, shape and volume. And then we have 2 basic types of solids. We have amorphous and we have crystalline. Okay, amorphous solids can change shape over time. They don't really have a perfect orderly arrangement. If you look at these particles of the amorphous solid compared to the crystalline solid, there's a perfect order. These are gridlocked into place. And one example over here is cotton candy. If you just leave the cotton candy alone, it will keep its shape, but of course you can bend it. Another example would be the rubber in a tire, or actually glass, like windows can change shape over time. Over time, the bottom of the window will be actually thicker compared to the top due to gravity. However, with crystalline solids, the particles are very orderly, and the result is an actual crystal. Okay. Liquids, you can click here to read more about liquids. This is the second lowest energy state. The molecules are close together, but they can slide past each other. This is why you can easily pour a liquid, like milk, onto your cereal in the morning or something. It does have a fixed volume. I'll demonstrate this in class. But it does take the shape of its container. You know this all too well. If you were to spill liquid on your keyboard, it would find every little crevice and it would take that shape, which is not always necessarily a good thing. We have a new word, viscosity. This is the resistance to flow. So the thicker a liquid is, the more viscous it is. Honey is quite viscous. Vinegar is not. This flows very well, just like water. I'm sure you can think of some other liquids that fall along that scale. Okay. Next, we have gases. Click here to read about those. This is the next highest energy level, so it's higher than a liquid but lower than a plasma. The molecules are very spread out. They have lots of energy and they zoom all around their container. And so they do take the shape and volume of the container. If we were to take this container and pressurize it and cut it in half, then the volume of the gas then would obviously be cut in half. But yes, they spread out to fill the shape and volume of their container. They are subject to the pressure of the atmosphere, so if they're under high pressure, they will take up less volume. If there's not a whole lot of pressure, then they will expand and take up more space. Later on, probably in the coming week, we will talk more about 2 specific gas laws, Boyle's law and Charles' law. This involves a lot of very fun demonstrations, and we will get Mr. Tilley involved as well. So just know that that's coming. Okay. Lastly, this is your last slide for today. Plasma. Click here to read about plasma. We are so lucky here in Alaska. We get to see one of the coolest plasmas ever, the Northern Lights. Again, plasma, like a gas, takes the shape and volume of its container, sorry. It is basically electricity running through, and that's what can create these cool colors. It depends on the actual gases that are there, but depending on whatever they are, that will give you different colors. Plasmas naturally occur as northern lights, stars, and flames. There are many more. Read more about that here. And we can also make them artificially, meaning man-made, human-made, in neon lights and fluorescent lights in signs on the streets and such. So that's it. Tried to keep this very short. I'm sorry if I talked too quickly. You can always rewind. Thanks for listening.